Hello, welcome to my video. Join me as I explain the inverse of a function. Let's have some fun.
Your temperature is 97 degrees Fahrenheit. I need it in degrees Celsius.
Today is your lucky day. I can help you today. Let me explain the inverse of a function.
So this is the problem the security guard is facing. Here it is, he scanned the person for their temperature and the machine show 97 degrees Fahrenheit. He would like to be able to switch the Fahrenheit back to degrees Celsius. He doesn't quite know exactly how to do that switch on his thermal laser gun. Alright, now he used to pay attention a lot in science class. Alright, now why degrees Celsius? Why that particular unit? Well, in many Caribbean island states, we use degrees Celsius as our unit of temperature. And for us to know whether or not the person is running a fever, and if to allow the person a compound, we need to know exactly what is his temperature in degrees Celsius, because this is what is the information given to security. Right, within a particular range, you allow certain people in a compound or not. Alright, because a fever would suggest that something health-wise is wrong. Now, from the school days of the security guard, right, he remember how to convert degrees Celsius to Fahrenheit, but he didn't quite remember how to switch around, meaning to take degrees Fahrenheit and convert back to degrees Celsius. Now, what he remembered was that if you take the temperature in degrees Celsius and multiply by 9/5, and you come and you add to 32, you'll get your answer here in degrees Fahrenheit. Right? Now, for him to determine whether or not the person is running a fever or not, the information given to him is a particular temperature range in degrees Celsius. So he needs to be able to convert this, unless he figures out how to get the thermal laser gun to actually make the switch. So to do this, he needs to know how to do the reverse process, and this is the dilemma that he is in right now. Alright, and the cool dude is presently volunteering his knowledge and expertise to our security guard. So next up, let's check out what happens to our security guard and the cool dude.
You are within range. Go ahead.
You seem to be guessing. I shall explain the inverse of a function to you.
To determine the inverse of a function, we need to know some things before we reach here. So we need to have a checklist of things first that we must have clear in our minds, that we need to understand first before we begin to understand the inverse of a function. Because without a clear understanding of this, we're going to have trouble later on. Alright, so what are some things that we need to know first? Alright, so the first thing you need to know is what is a relation and the types of relation. Alright, now this would have been covered in your previous years of secondary schooling and in previous lessons. Alright, this would have been covered there. Alright, so we do understand what is a relation, the types of relation. You need to go back and actually examine that first. Alright, the second thing we need to understand is mapping diagrams. That is creating a visual of the relation. Alright, what is your domain and what is your range? Alright, or as the case may be, your codomain or range. Third thing we need to understand is what is a function. Okay, without understanding what is a function, we are going nowhere. Because after we are determining the inverse of a function, what are we after? The inverse of a function. Alright? Alright, the last thing is to transpose the formulae. Alright, so we need to know how to transpose a formula as well. Alright, now when we have these things clear in our minds, then we can progress to the inverse of a function. Okay, let's move on. so far we have established the checklist of things that we need to know. One of the things that is on that checklist is a mapping diagram. And the mapping diagram allows us to create a visual as to who or what is an inverse function. Alright, let us begin with just constructing the mapping diagram itself. You know, every mapping diagram must have a domain and must have a range or a codomain, which we generally call Y. Your domain is X and your range or codomain is Y. Alright? So here's your X, here's your Y. Alright? So how your f of x or your function goes, your mapping of your function. Generally use the letter f to represent the function. You could use g as well. Alright, but typically the convention we use f. So f of x, f for function. Alright, so you see that the mapping goes from your domain to your range. And it's a typical mapping diagram. Now your inverse function, on the other hand, what it does, it takes the elements from your range and it map it back to your domain. So it really is a reverse mapping. See, this symbol here, this f superscript -1, really means inverse function. This symbol means inverse function. Alright, so you see that this takes the elements from your range back to your domain. Alright, you could think of the inverse function like a return flight. Right? Like a return flight. For example, suppose you were flying from Trinidad and Tobago to Jamaica. Okay, the idea is I go in there for a vacation, not to spend the rest of your life across there. So one day in the future you would like to be able to take a flight from Jamaica back to your home country, which is Trinidad and Tobago. Alright, so you can think of this like a return flight, a return path. Alright, so if and when travel resumes back to normal, alright, you could think of this like a return flight. Okay, unless of course you plan to spend the rest of your life in another country, in which case that's a whole different scenario. Alright, so what this really is. Alright, so simply put, what this inverse of a function is supposed to be is really a mapping from the range to the domain. Can be interpreted as a reverse mapping. See, going in the reverse direction. Alright, here is you could think of it like a car. You're going from point A to point B, but you would like to go from point B back to point A. Right? Unless point B is your home. Alright, I plan to spend a significant amount of time across at point B. Anyway, that's a discussion for another time. Alright, so it is really a reverse mapping. This is what it is visually. This is what you're really doing in effect. Alright, so from here we are going to outline the steps involved in determining the inverse of a function. Alright, so stay with me, hang on. What are the steps involved in determining the inverse of a function? If we list this out into steps, what should it be? We start off by stating what is the function. This is usually supplied to us in the problem. Most times, most problems supply the function either using f of x or g of x. This is given to us in the problem. Alright, we start off by saying let y equal to f of x or let y equal to g of x. And f of x or g of x could be an algebraic expression. Alright, so we started by saying that y equal to some algebraic expression, most times in terms of x. Alright, the second thing is that wherever you have y, you interchange with x. Alright, wherever you have x, you interchange with y. That is, you do a variable interchange. Alright, so there's an interchange of variables. That is, swapping x with y and y with x. Alright, wherever you see x, you replace with y. Wherever you see y, you replace with x. So there's a change around. Alright, next step that follows is that you make y the subject of the equation. Here it is, everything that you know about transposing the formula comes into play. So after you make y the subject of the equation, guess what? Now we could conclude that you have determined the inverse of the function. This here is your conclusion step. Alright, very much like an essay. This is your conclusion. Now we can conclude that you have determined the inverse of a function. And usually you use this notation, f superscript -1 open bracket x close bracket. This notation here is used to mean f inverse of x. Or if your problem has started off with g of x, guess what? It will be g inverse of x. That is g superscript -1 x. Right? Or just simply put g inverse x. And then from there, congratulations, you have just found the inverse of a function.
Audio Jungle. Audio Jungle.
Alright, so we have some worked examples here in which you're going to actually take functions that supply to us, and we're going to use the steps from before and going to determine the inverse of the function. Alright, so the function here is f of x equal to 4x plus 3. Notice the highest power of x here is 1. So it's 4x plus 3. So it's linear. Alright, so we are supplied with f of x, right, the function as f of 4x plus 3. We don't need to guess this, we are given this. Alright, so solution. Start off by stating what is your function. F of x equal to 4x plus 3. Let y equal to 4x plus 3. Alright, so you see you let y equal to that. So here's your step 1. Step 2, you're going to interchange variables. Alright, when you interchange variables, this means wherever you see y, you replace with x. Wherever you see x, you replace with y. So you end up with this here, 4x plus 3. Alright, now you're going to isolate the y term by itself. Alright, meaning you're going to make y the subject of the formula. Alright, so you get x minus 3 is equal to 4y. So therefore you get y is equal to x minus 3 on 4. So here's your step 3. Step 4, go ahead now and make a conclusion. So here's your step 4. F inverse of x equal to that. And with that comes success. Simple. Follow these 4 simple steps and I guarantee you success every given time. Alright, so this is just one example. Let's move on to another example. So you want to determine the inverse of the function g of x equal to 1 divided by 4x plus 3. Now 1 divided by 4x plus 3 is what we refer to in maths as a reciprocal function, because you have 1 over algebraic expression. Alright, your numerator is 1, your denominator here is 4x plus 3. See, your numerator is 1, your denominator as a bottom piece is 4x plus 3, and your line in between is what we refer to as a vinculum. Alright, so it's 1 over that. So this is what we refer to as reciprocal function. So what is the solution of this? So we start off by saying g of x equal to 1 over 4x plus 3, we say let y equal to 1 over 4x plus 3. So y here becomes a dummy variable. Alright, so instead of using g of x all the time, we refer to g of x as y. Alright, so this y here is what we use instead of the g of x. So you can think of y as a dummy variable. So you say let y equal to 1 over 4x plus 3. So this here is your step 1. Now your step 2 is that you're going to have interchange of variables. So wherever I see y, you replace with x. Wherever I see x, you replace with y. What is the end result? X is equal to 1 divided by 4y plus 3. Alright, now from here, you want to transpose and make y the subject of the formula. How are we going about doing this? We're going to cross multiply and we're going to perform transposing the formula. So when you cross multiply, you get x times 4y plus 3 is equal to 1. After you perform the transposing, you get y is equal to 1 minus 3x divided by 4x. How did I get that? I take the x and multiply by the 4y. I take the x and multiply by 3. Alright, so I expand the brackets here. And from there, I simplify. I end up with this expression. The details of this, I left this out for you all to figure out. Right, I left this out here. Right, for you all to figure out. Right, due to the space limitations, I left this out for you all to. It's not difficult. Alright, again, assuming you know how to transpose a formula. Alright, so next thing after this, so you make y as the only variable on one side. Right, is what is meant by transposing. Y is the only variable on one side of the equation. Alright, you have all your y terms here and you have all your x terms here. Alright, now the next step after this is your conclusion step. Now we have started off with g of x. What we're interested in getting, g inverse of x. And we use this notation here, g superscript -1 x. Alright, this here denotes the g inverse of x. This notation, this simple notation here. Alright, simply means g inverse of x. Now g inverse of x is equal to 1 minus 3x divided by 4x. This is our conclusive step. Alright, now this comes with a limitation. See, in the denominator you have 4x here. Alright, if you ever have a scenario where x is equal to 0, then guess what? You get 4 times 0. And then you have division by 0. Once you have division by 0, then you cannot get a value. Is what they refer to in maths as indeterminate, meaning that no real value or no value exists. Alright, no value exists. If you was to divide anything by 0 and you punch it in the calculator would not be able to evaluate that. Alright, so to get rid of all that drama and all that mess, we just simply put this is valid that provided that x is not equal to 0. Alright, once x is not equal to 0, this would be your inverse function. However, if x was equal to 0, this inverse function will cease to exist. And then from there, we can say success. Alright, so let's move on. Alright, so another example here, when you determine the inverse of f of x equal to 3x plus 2 divided by 4x minus 3. Here it is, we are given this as our function. 3x plus 2 divided by 4x minus 3. Alright, this is another example of a reciprocal function. Alright, more of reciprocal functions shall be discussed at your Form 6 level or CSEC level. Alright, you shall just work with the function as given to us. Okay, however, we reach the Form 6 level, we will be discussing the whole idea of a reciprocal function in much more detail. But right now our goal is just to determine the inverse of this. Alright, so what's the solution? So the solution of this Alright, we start off by saying that y is equal to 3x plus 2 divided by 4x minus 3. We do a switch around, we do a swap of the x and y variables. So I'm getting this here. So this is your step 1, here's your step 2. Step 1 here, here's step 2. Alright, here do a swapping of variables. Alright, Alright, so the idea is to make y the subject of the formula. That is to isolate y as the only term. Alright, on one side of the equation. Alright, so you have y by itself, isolated. Y by itself. So you're transposing this. Alright, so after you perform the cross multiplication, you get this here. We keep on simplifying and we end up with this here. Y is equal to 3x plus 2 divided by 4x minus 3. Alright, I left out the details for you want to perform. But after performing the details, you end up with this here. Alright, so this here is the transposing, so this is a step 3. And from here you can conclude that the f inverse of x is equal to this. F inverse of x is equal to 3x plus 2 divided by 4x minus 3. Now this would cease to exist at x equal to 3/4. How did I get that? Well, what did I just say about division by 0? If you have division by 0 occurring, then you can have indeterminate, you cannot get a value. So it ceases to exist whenever this is equal to 0. So to get this, we say 4x minus 3 is equal to 0. We solve for x. And I'm getting x equal to 3/4. Alright, so f inverse of x is valid provided x is not equal to 3/4. Because if x was ever equal to 3/4, you're going to have division by 0. This is going to have division here by 0. And this will cease to exist. You get indeterminate. The calculator cannot process that. Alright, for now, for the time being. Alright, you cannot work out the value for indeterminate function. So to make life easier, we just simply put x is not equal to 3/4. Alright, and with this leads to success. Alright, so follow these 4 simple steps and you will get it out each and every time. Alright, so to summarize now, to recap, what were the steps involved in determining the inverse of a function? You start off by stating the function. Alright, the function itself. Alright, f of x equal to whatever, g of x equal to whatever. Alright, and then from there you see that y equal to whatever the function is. Alright, so that y equal to f of x or that y equal to g of x. Alright, second step, you interchange variables. That is here, wherever you have x, you replace with y, wherever you see y, you replace with x. And from there you make y the subject of the equation. And meaning a transpose, meaning that you isolate the y term by itself. Alright, and the fourth step is that you conclude that you have determined the inverse of a function. Usually you have this symbol here, which means f inverse of x or g inverse of x. Alright, usually f inverse f of x or g of x are used, common notations are used to represent the functions. Follow these 4 simple steps and it will be easy sailing and easy marks to get in any question. Alright everyone, so 4 simple steps to follow. Alright, and you will get through it.
Audio Jungle. Audio Jungle.
Alright, back to our initial problem. So we started off here with degrees Fahrenheit is equal to 32 plus 9/5 degrees Celsius. Now we want to get degrees Celsius as the subject of the equation. Alright, meaning to have degrees Celsius here as the only variable by itself. Alright, in order to simplify everything, let's just make degrees Fahrenheit to be y, and let's just make degrees Celsius to be x. what end up happening is you get y is equal to 32 plus 9/5 x. This 32 plus 9/5 x becomes your f of x. You can actually replace this with f of x. So essentially what you're doing is that y, which is equal to f of x, is equal to 32 plus 9/5 x. Alright? And then from there, so we start with step 1 here. Here's just step 1. Let y equal to the function. Alright. So now what follows afterwards is that we actually interchange the variables. So wherever you have y, this becomes x. Wherever you have x, this becomes y. So you're swapping variables here. So wherever you have y, this becomes x. Wherever you have x, this becomes y. Alright, so it is literally a swapping of the variables. Alright, now what follows next is we're going to transpose and make y the subject of the formula, meaning that we're going to have y as the only variable on one side for isolating the y term. Alright, so we are transposing here. Alright, so you get x minus 32 is equal to 9 on 5 by y, and I'm getting that y is equal to x minus 32 by 5/9. Alright, this here, you can conclude this is our inverse function. Our inverse function, f inverse of x, is equal to x minus 32 by 5/9. Alright, so this means a degree Celsius is really equal to degrees Fahrenheit minus 32 times 5/9. Alright, now when we substitute our temperature readings, alright, our degrees Fahrenheit here was 97. 97 minus 32 and multiply by 5/9. This works out to be 36.1 degrees Celsius. Alright, now 36.1 degrees Celsius, that is within range. Alright, the person is not running a fever. So the conclusion the security guard can make is that the cool dude is not running a fever. He's not running a fever, and he can't be allowed to enter the compound. Alright, so this is the decision. This is what the security guard can conclude out of all of this. Alright, so the cool dude can actually enter the compound. Alright then, I hope this clears up this situation that the security guard is in. Alright, and hopefully, thanks for watching. Hope you learned something out of this.